Hello, welcome. Let's try to solve another Leetcode problem, 280, wiggle sort. So we are given an array nums, reordered it such that nums 0 less than or equal to nums 1, nums 1 more than or equal to nums 2, nums 2 less than or equal to nums 3. So it will be like this. So from the beginning, this is nums 0. So it should be less than, so it means increase and decrease, increase and decrease. So this is the meaning of a wiggle sort. So we are getting a random array nums, and there can be duplicate numbers. So for example, there are 6, they are duplicate. Yeah, because we have the nums 0 less than or equal to nums 1. We have this kind of condition. So it means even there are equal numbers, it should be okay. So what are we going to return? We are getting a random number. The random number may be like this or this, we don't know. But finally, it's going to be increase, decrease, like this kind of curves. Yeah. So the first method, I think we can solve it like this. We're going to sort the array nums. So currently we have this kind of example. If we have an array like this, so after sorting, we're going to have like 1, 2, 3, 4, 5, 6. We have this kind of array. Now we're gonna prepare our nums, and inside the nums we're gonna choose the number. First of all, we're gonna choose the minimum number, it is 1, and then we're gonna choose the maximum number, it's gonna 6. After that, we're gonna choose the minimum number 2, and then we're gonna choose the maximum number, it's gonna be 5, and then we're gonna choose the minimum number, it is 3. After that, we're going to choose the maximum number, it's going to be 4. So in this way, it's going to be increasing, decreasing, increasing, decreasing, and increasing. So it's going to be the wiggle sort. So this is one way to solve the problem. So first of all, we're going to sort the array. Yeah, but we need a copy of the array. So we need some on space. But we need the time complexity going to be n log n. So after sorting, we're going to put the sorted array, put each of the nums inside of the sorted array to our nums. And then we just finish the question because we don't need to return anything, just modify nums in place instead. Yeah. Now let's try to solve it in this way. So first of all, I'm going to prepare a copy of nums. So I'm going to use the sorted nums. So this is a copy of nums, and this array has been sorted in increasing order. And then I'm gonna use the two pointers to check the minimum and maximum value inside the array. So L and R should be equal to 0 and length of the array minus 1. And I also need to use an index to point the position of the nums. So I'm gonna prepare the index to be 0 from the beginning, and then I'm gonna start. So while L and less than R, so this is the two pointer method. So inside nums, so nums I should equal to the so from the beginning it's gonna be the minimum number because we want to increasing and decreasing. So it's gonna be the array L, and then L should plus equal to 1. Yeah, but we need to check with this index. So if this index is even, so this means the index is 0. If it is even, what are we gonna do? We're gonna choose the smallest number. If it is even, we're gonna choose the smallest number. So it is array L. So from the beginning, L equal to 0. So we need to have a check. So if I modulo 2 equals to 0, so this means it is even. So we're gonna choose the smallest. Otherwise, we're gonna choose the maximum. So I just need to copy and change it to nums R. Nums I should equal to array R, gonna be the maximum, and the R should be minus 1. Yeah. Now after that, this I pointer should plus equal to 1 because we've already finished one position of the nums. So for example, we finished the first place and then we're gonna choose the second place. This is why I need to plus 1. So this is gonna be the final code. Now let me just run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed and it's pretty fast. So the time complexity is n log n and the space complexity is O(n). Yeah. So maybe we want to optimize it. Let's try to optimize the space. So why we need the actual memory? Why not just do it in place? Yeah. So I gonna still use the nums array. So nums gonna sort it in place. So after sorting, I will try some other method to solve it. So after sorting, we have an array like 1, 2, 3, 4, 5, and 6. As we already know, 1 must be okay because it is sorted in increasing order. 1 must be the smallest. So I'm gonna start in from index 1. So it means this number 2. Yeah. So from here, I'm gonna swap 2 numbers as a group. So from the index 1, I'm gonna swap 2 and 3, and then I'm gonna jump to index 3, I'm gonna swap 4 and 5, and then I'm gonna jump to index 5. If it goes out of the range, I'm gonna stop. So this means for index 1, I'm gonna swap 2 and 3, so it's gonna be 3 and 2. After that, I'm gonna jump 2 steps. I will go to index 3, it's gonna be 4 and 5. So I'm gonna swap 4 and 5, it's gonna be 5 and 4. And then I'm gonna jump to index 7, but this index goes out of the range, so I'm gonna stop. Yeah. But what left behind inside the nums, inside this nums, it's gonna still be the 6. So it should be okay, as you can see, increasing, decreasing, increasing, decreasing, and increasing. Yeah, so we're gonna solve it like this. So for I in range from 1 to we're gonna prepare a variable n. So this n gonna be length of the nums. So we're gonna use from 1 to n with 2 steps. So we're gonna have a check. So as I said, we're gonna sample two steps. Yeah. So from the beginning, the index is 1, and then we're gonna jump to index 3. Yeah. But for this jump, we have to check because we're gonna use nums I and nums I plus 1. So we need to have a check if I plus 1 and less than n. Yeah, because if I plus 1 more than n, it's gonna have exception error because this I will go out of the range. Yeah, so we have to check it. So if I plus 1 less than 0, so we're gonna swap 2 numbers. It means nums I and nums I plus 1 would be swapped with nums I plus 1 and nums I. So after swapping, everything should be okay. Yeah. So, but we need to jump 2 steps. So this is a step of two steps. So it should be okay. So after jumping, if this I plus 1 less than 0, so it's gonna swap. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check. Now the time complexity is n log n, but the space complexity is O(n). We didn't use any actual space. So this is a better way to solve the problem. But this is not the optimum. The optimum way is follow up. Could you solve the problem in O(n) time complexity? Now we try to use O(n) time to solve the problem. It's gonna be a little bit harder. But basically we need to find some patterns of this example. As you can see, it is 3 and 5. If this 3 is less than 5, normally this 2 is okay. Yeah, so we're gonna check the next one. So what about 5 and 2? So if this 5 and 2 is okay, 5 is less than 2, and this 5 is in the index of the 5 is odd. It is less than 2, it is okay. Now we're gonna check the next index. This index is 2, So 2 should be yeah, so it is decreasing, should be increasing. Yeah, so 2 normally should be, yeah, let me check one by one. So we're gonna check, yeah, we're gonna check the group. Also we're gonna check two numbers. Of course we're gonna compare with two numbers, but we're gonna check from index 1, because this one from index 1 we can always compare with the previous index. It is index 0. So we're gonna use this 5 to compare with 3. So let's just have a check. 5 compare with 3. 5 is more than 3. It is okay, because according to the pattern it should be increasing. It is okay. And 5 less than 2, it is also okay. Yeah. Now we checked the index 2. So what about we check this index 3? So this index 3 should be more than and equal to this index 2, but it is not. As you can see, this index, this 1 should be more than 2, but it is not. So what we can do? We're gonna just swap it. Swap 1 and 2. Yeah, so currently if the index is odd, and this number should be, the odd index number should be bigger than the previous number, but it is smaller, what are we gonna do? We just swap it, so it's gonna be 1 and 2. Yeah. Now we are safe, because if this this number 1, if it is less than 2, definitely this 1 is less than 5. Why? Because 2 is less than 5 and 1 is less than 2. So definitely 1 is less than 5. So this means after swapping, this 1 definitely it is less than 5. So it's gonna meet all the conditions, because we only need to compare with 5, and the value before 5 we don't need to check because it has already met the conditions, right? Now it seems okay. Now we're gonna check the next one. So next number, yeah, so it is increasing, decreasing, increasing, decreasing. Next number should be, yeah, should be, yeah, this is decreasing, increasing, and the next number should be decreasing. Yeah, because next number is 6. Yeah, but it is not like that. As you can see, 6 is more than 2, but it should be decreasing. So what are we gonna do? We're gonna swap 6 with 2. So here gonna be 6, and here gonna be 2. Now we're gonna check the last number. So it is decreasing, and the last number should be increasing. It is okay, so we're gonna keep it. Now we've already finished it just in on time and on1 space, because as you can see, increasing, decreasing, increasing, decreasing, and increasing. So yeah, we still need to check the index. So let's just start coding. So for I in range, we're gonna start from the index 1, and to the length of nums. So we're gonna have a check of this index first. So if this index is yeah, so if this index is even, we're gonna start from index 1. So let's check the odd first. So if this index is odd and this number is smaller than the previous number, and nums I is smaller than the previous number, this means we need to do a swap, and the previous number is I and minus 1. So this means we're gonna swap nums I and nums I minus 1 with nums I minus 1 and nums I. And we also need to check another condition, that is I index modulo 2 is even. So if it is even, it is this number, but it is bigger than the previous number, we need to have a swap. Let me just copy. So if it is bigger than the previous number, we need another swap. Yeah. So this is gonna be the final code. Now let me just clean up a little bit about the code. So we can use or to check the two conditions. Yeah, so from here we're gonna use or to check the conditions. And finally we can delete those two lines. Yeah, we're gonna just keep it as 3 lines, but we have a lot of check. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass. Now as you can see, it passed and it's pretty fast. Now let's analyze the time and space. The time becomes ON and the space becomes O1. So this is gonna be the optimum solution, and this is the best solution. Thank you for watching. See you next time.